Alright, good morning. I need you guys to get out all the handouts from last Friday. That's the same pages that were on the front desk this morning, so if you were not here on Friday, you need to grab those copies, but if you were here Friday, you should have those already. But it was a long assignment, so we did not finish that, so that is our assignment again today. So go ahead and get that out. And I'll give you a couple minutes to get sorted. Okay, so what we started with last time is this big handout. We had on the front page, there was a big box where we were putting all of our notes for rational functions. And that looks like this. So, one single place where you can refer to all of these different things. It's a lot of information. But luckily, if you know the information, it's not usually much work. So we had these three that we talked about the first day at the end of the quiz. So x-intercepts, vertical asymptotes, and holes. All of those require you to know what numbers make the numerator 0, what numbers make the denominator 0, and depending on if it makes just the numerator 0 or both, or just a denominator 0 or both, you could get different things. We talked about y-intercept is where you plug in 0 for x and solve for y. So that is one of the easier ones for most people. The 3 rules for horizontal asymptotes. Domain is pretty much a review from what we've been doing. And then slant asymptotes, knowing when to take a slant asymptote and how to do it. All of that is summarized there. So I really encouraged you last time to consider this, but again today, as you work these questions, if you realize, hey, I'm just missing all the horizontal asymptote questions, you might go back and give yourself some examples or put it in more details or something like that. But if I remember right, I think number 6 was the last one that you guys did. Is that correct? I think you did 6 and then that was the end of class. Okay. So what I'd like to do is I'd like to go over number 6 with you. So you should already have this one done. So then you get some quick feedback about where you were on Friday. I'll go over number 7 with you so that I can repeat all of these rules again. And then we will, I'll give you time to do the rest, but we'll do those one at a time with guided practice. Okay, so when you do these, again, I highly suggest you start with whatever you think is easier and then work your way out to whatever you think is hardest. There's nothing wrong with that. So me personally, y-intercept is usually one of the easiest. Plug in 0 for all the x's and solve for y. You get -4 over -16, which reduces to 1/4. So on your graph and your table, I guess, you should have a 0.014. Again, if you know what to do, notice how I was able to go straight to my answer. I don't need multiple steps of work. Okay, for these three, these are the ones that we've seen 2 different class periods. This would be the 3rd class period. You need to know what numbers make the numerator 0 and the denominator 0. So sometimes you need to factor, like the denominator. Sometimes you don't, like the numerator. But if you have a number that makes both the numerator and denominator 0, you get a whole. Any number that makes just the numerator 0 is an x-intercept, which is going to be another point for our table and graph. And any number that makes just the denominator 0 is a vertical asymptote. Again, the sooner you feel comfortable with those rules, the sooner you can work those as quickly as I did. Domain's a little bit easier to do once you have the graph. Horizontal asymptotes is where you compare the degrees. If the degree of the denominator is bigger, it's y equals 0. If the degree of the numerator is bigger, it doesn't have one. And if the degrees are equal, you need to do y equals leading coefficient over leading coefficient. So you should have had -1/4, y equals -1/4. And then slant asymptote is probably the one that's the most amount of work, but it's only if the degree of the numerator is 1 bigger than the degree of the denominator, which is not the case here. If it was the case, we have to do long division, and it would be y equals the quotient, ignore the remainder. So, if you found that stuff correctly, your graph should have a point at 4, 0, and 0, 1/4. You should have a vertical asymptote at x equals -4 and y equals -1/4. Some questions you really need to find some more points. Some questions it's a good idea to find more points. It just makes your graph a little more accurate and gives you some confidence. But realistically, this was enough on this question if you remember how it behaves around the asymptotes. For slant asymptotes and horizontal asymptotes, it tells you how the graph approaches at the far right and the far left. Based on this, I can tell that the direction of this graph, this guy was heading up. Vertical asymptotes, it's either spiking to infinity or negative infinity. And if it spikes to infinity on this side, it's going to be negative infinity on that side. And just like it approaches the horizontal asymptote on the right, it needs to approach the horizontal asymptote on the left. So again, more points would have added some confidence to your work, but that's what you should have been aiming for. Now that I have the graph in front of me, I can go back and do domain pretty quickly. I'm hitting all the x values before -4 and all the x values after -4. Okay, so I'm going through that one pretty quickly because you guys should have done that one and we were just kind of looking for mistakes there. Okay, anything that jumps out at you? Any questions you have ready to go about that? Okay, then let's do number 7 one more time. This one I'll do for you. You have not practiced this one yet. It's kind of a balance where you guys need to hear these rules a handful of times, but at some point, me saying the same rules over and over, I don't know, it gets kind of drowned out. So I guess if I start off this question like I did the last question, I would probably do y-intercept, plug 0 in for x, you get 4 over -6. That reduces. So we got 1 point for our graph already. These 3 require me to know what numbers make the numerator 0. That's pretty easy because it's already factored. And the denominator 0. That one requires that you factor it, GCF. Well, I guess it doesn't require, but it's easier. If you had a number that made both the numerator and denominator 0 at the same time, you would have a whole. That's not the case here. Any number that makes just the numerator 0 is an x-intercept, and any number that makes just the denominator 0 is a vertical asymptote. Factoring these and figuring out where they equal 0 can be a pain. Question 8 looks like it's going to be the harder version of that. But once you have those, these 3 answers should kind of fall into place quickly. Okay, horizontal asymptote, compare the degrees. Since they are equal, it should be y equals leading coefficient over leading coefficient. If it has a slant horizontal asymptote, it can't have a slant asymptote. To have a slant asymptote, the degree of the numerator has to be 1 bigger than the degree of the denominator. So that's going to take a couple minutes when we have to do it, but if it doesn't have one, it should be about a 5-second question. And so we've got 2 points from this required questions anyway, and 2 asymptotes. So if we start to throw all that stuff on our graph, we should be close to knowing what our function looks like. Okay, and this looks like this one's going to be an easy graph. Since this has to approach the horizontal asymptote on the right and the left, that's that part of the graphs. Based on the direction of this one, he's going up on the left, and based on this guy's direction, he's going down on the right. Everything is nice and consistent. Usually if you miss a part or two of this, bless you, if you miss a question or two, usually your graph looks very confusing, and it usually gives you a hint that something must not be right. Everything's got to kind of fit together. Okay, and now that I've got this in front of me, I can see the domain is negative infinity to negative 3, and then negative 3 to infinity. Just need to write it up in this blank. Again, I know I'm going over these rules quickly, and a few of them you may not be comfortable with, but I will pause and give you plenty of time to ask questions. So, anything you would like to ask about question 7, anything that you know you don't quite understand yet, before I give you some time to do 8. Yeah, so domain is a way to describe the x values that the graph is hitting. So I can see that it's going to hit all of these x values over here. So this would be from the far left until you get to negative 3. And then I can't plug in negative 3 because it's division by 0. Doesn't matter if it's a whole division by 0 or if it's a vertical asymptote division by 0. You shouldn't include it. And then I can hit all of these x values, which are negative 3 to infinity. Okay, others? Okay, then let me give you about 7 minutes. I won't give you as much time as we move on today, but 7 minutes to give your best effort on question 8. And while you do that, I'm going to graph it up here on the board. So as you finish, you can scan it, and if your graph looks the same, then most of your work is probably fine. But I'll tell you the couple things that could still be wrong. But go ahead and try all of 8, and when you finish, well, if you get stuck, use your notes on the front page, and then when you finish or run out of time, glance up at the board and see how close your graph ended up to the actual graph. And of course, go ahead and just keep going. Move on if you're completely stuck or if you're completely finished with what you can do. Okay, about 2 more minutes on this one. Okay, so again, for this question, you can check most of your answers by your graph. For example, if you thought there was 2 vertical asymptotes, your graph is not going to look the same because there's only this one, this vertical spike right here. If you did not get 2 x-intercepts, because there's only 2 x-intercepts, and that's a red flag. This is a little bit harder to see, but there is a slant asymptote here. So if you thought there was not a slant asymptote, then that would be something you need to pay attention to. So most of these questions can be checked by just seeing if your graph looks the same, but I will warn you, there's 2 of them that your calculator does not help you with, or does not help confirm or deny. That would be domain and holes, because your calculator does not show the holes very well. So I'll go ahead and do these 2 first. That way, for those of you that had the graph looking good, you can just move on to question 9. You don't have to wait. But then I'll go over all the rest of it. Okay, so for holes, I need to figure out what numbers make the numerator and denominator equal to 0. So I'm going to look at how the numerator factors had a GCF and a difference of 2 squares. 3 numbers made the numerator 0. The denominator also had a GCF and then a trinomial. And just for full disclosure, this one I did not factor correctly in 0 hour this morning, so that meant I had to go back and redo a bunch of work. Be careful with your factoring. Okay, and for the holes, it looks like x equals 3 will be a hole because it makes the numerator and denominator 0 at the same time. The y value of the hole is where I'm very concerned though. Again, this is just one of those things that just doesn't stick as well with students, and I think it's just because you don't get to practice it on every question. It's like every 3rd or every 4th question you get to practice it. But you have to plug in the x value of the hole, not into the function, you're going to get 0 over 0. Not into the factored form, you're still going to get 0 over 0. You need to plug it into the reduced fraction. Let this x minus 3 cancel out this x minus 3, and then plug it into what's left. And you would end up with 3 over 2 after it reduces. Okay, and then for the domain, now I can see that there's 2 numbers that's division by 0, so these are the 2 numbers that are going to be taken out of the domain. Again, I think it's easier to do domain after you look at the graph, but I'm just starting this so that the people who had a correct looking graph can know if they're on the right track and can move on or not. So those are the 2 things you could not see from the graph. Okay, now for the rest of it, y-intercept, if I plug in 0 for all these x's, I get 0 divided by -9, which would be 0. I've got 2 numbers that make only the numerator 0, 0 and -3, so those should be my x-intercepts. This one should make sense. The origin is not just a y-intercept, the origin is also an x-intercept, so it's good to see that those are both showing up as they should. And then vertical asymptotes are for any number that makes just a denominator 0. If it's both, it's a hole. If it's just numerator, it's an x-intercept. And if it's just a denominator, it's vertical asymptote. None of this should be overlapping. Each of these are completely unique things. Okay, horizontal asymptote. The degree of the numerator is bigger, so it doesn't have a horizontal asymptote. But because the degree of the numerator is 1 bigger than the degree of the denominator, that's what forces this to have a slant asymptote. Now for the slant asymptote, I guess you could miss this too, but if your graph looks close, then you're probably right. But to get the slant asymptote, you will need to do long division. You might put in a placeholder if that helps. You can say 0x squareds if you want. And our slant asymptote is going to come from just the quotient. Whatever the remainder is does not matter. Doesn't affect it. So the first part should have been 1/3 x, because 1/3 times 3 is 1. X times x squared is x cubed. Also 1/3 times -6x. So do this in 3 parts if you need to. Positive times a negative would be negative. 1/3 times 6 would be 2. And x times x would be x squared. Okay, for advisory?
No, they're by class.
Oh, your class. Okay, I'll go check on it in a minute. Okay, and then 1/3 x times -9. So positive times a negative would be negative. 1/3 times 9 would be 3. Multiplying by a third is dividing by 3. And x times no more x's is x. Now you can see I did these two out of order. I'm just trying to line them up. It just makes it a little bit easier. Change the signs and add. I'm going to put this up front because it's an x squared. Okay, and then you could go just one more time before we get down to the remainder. So we had to think of the number times 3x squared to get 2x squared. So if I do 1/3, 1/3 times 3 would be 1, but I need it to be 2. So just double it and make it 2/3. And then positive times negative is negative. 6 divided by 3 would be 2. Times this 2 would be 4. And this times this, positive times a negative would be negative. 9 divided by 3 would be 3. Times 2 would be 6. Doesn't matter as much because, again, the remainder doesn't matter. It's just the quotient. So if you make a careless mistake at the end of these long divisions, you should still be okay. Now, in all of that mess, we've got a few points, like the x-intercepts. We've got a hole, which you have to put down as an open circle. That's part of getting the graph correct. You need to show the hole. We've got 2 asymptotes, a vertical one and a slant one. This is an mx plus b, so this is like his y-intercept and his slope. Up 1, right 3. Okay, and then our graph is basically ready to go. So even though it doesn't hit this hole, it's going to hit the points before it and the points after it. I know that it has to approach the slant asymptote on the end, just like it would approach a horizontal asymptote. And then it's got to hit this point, this x-intercept that I'm sure about. Based on his direction, he must be going down on this side of the vertical asymptote, so up on this side of the vertical asymptote, which is good because otherwise how am I going to hit this other point that I was aware of? And not only does it approach the slant asymptote on the right side of the graph, but also the left side of the graph. So if I do a quick compare, my graph compared to the calculator's graph, very accurate considering I only spent a couple minutes on it. Now again, your calculator doesn't help some of this. Your calculator, even if we let you use a calculator, which we won't because it doesn't get us to test you on the stuff we need to, you're not going to notice the hole just glancing at the calculator's graph. Also, just because you have a slant asymptote, what did I say it was? Just because you know there's a slant asymptote, yours could still be wrong, I guess. But if you have your own calculator, my calculators are out today because of AP testing, but just a tip here, you can also graph this slant asymptote at the same time. If I said I think the slant asymptote is supposed to be 1/3 x plus 2/3, it should be this line that just fits in here perfectly. That's the equation of the slant. So when you have a calculator, also graphing your slant asymptote and seeing that it slides in perfectly there is a good idea. Of course, you can pull that up on Desmos too if you really want to do the graphing. Okay, so I tried to go at a reasonable speed here to help you kind of pick up mistakes that you made. Is there any specifics that I can help with before we scoot on to number 9? You either got it right or you saw what you missed. Okay. And if you have not started 9, please do. And same thing, I'm going to go ahead and graph it and leave the graph on the screen, and then that gives you a quick little check as you finish. And again, I'll give you about 7 minutes here. That was 7 minutes already. So if you got a graph similar to this for number 9, then you were probably in good shape with most of it. But if your graph did not look like that, you need to try to see what was different and what you might need to adjust. Okay, so just going in no particular order here. Y-intercept would be plugging in 0 for x, 0 minus 0 divided by 0 minus 0 minus 3. 0 divided by negative 3 would be 0. So that's why the y-intercept should be 0, 0. Okay, if you factored the numerator, you should have taken out a 3 and an x. So that you can see 0 and 4 make the numerator 0. The bottom was a trinomial, so guess and check or the product sum method. But all of that to see that 3 and negative 1 make the denominator 0. So x-intercepts are going to be numbers that make only the numerator 0. I already knew about 0, 0, but now also 4, 0. So that gave us a second point for our graph. Wholes are going to be numbers that make both the numerator and denominator 0, which didn't happen in this question. And then vertical asymptotes are going to be numbers that make just the denominator 0. Now, these are vertical lines, so if you guys are just writing these as numbers, you need to break that habit. You need to do x equals 3 and x equals negative 1. They're vertical lines, you need to write them as such. And even though those are not points, those certainly help us with our graph. Dashed line at x equals 3 and a dashed line at x equals negative 1. Okay, the domain, which is hard to check just from a calculator's graph, but domain, you've got to take out any number that makes it division by 0, regardless if it's division by 0 to create a whole or division by 0 to create a vertical asymptote. These are the two numbers that have to be taken out. You have to skip negative 1 and you have to skip 3. Always put the smaller number on the left of each interval. Horizontal asymptote rules, since the degrees are equal, it's y equals leading coefficient over leading coefficient, so y equals 3. Again, not a point, but should be a dashed line on our graph. Still helps out. And thankfully this one does not have a slant asymptote because the degree of the numerator is not 1 bigger than the degree of the denominator. So now that I've done all of this, and I've plotted the points, I've dashed in the asymptotes, most of the graph is completed. But before I go back and finish the graph, any of these parts that you want to ask questions about? Okay, then let's see. So with the graph, I'm pretty confident over here, because I know it has to approach the horizontal asymptote on the far right of the graph. And then based on this guy's direction, he must be going to negative infinity on the right side of this vertical asymptote, so positive infinity on the left side. Now, I think one thing that does mess or confuse students on this is you think that you can't cross a slant asymptote and you think that you can't cross a horizontal asymptote. That's not true. You can cross those. You can't cross them at the end of the graph because it approaches it at the end of the graph. But if your graph has more than 2 sections so that it has a middle, your graph certainly can and did cross the horizontal asymptote. That is perfectly fine. If you feel uncomfortable doing that on a quiz or a test, make yourself plug in 1 for x and solve for y, and then make yourself plug in 2 for x and solve for y. And when you see that these points are pushing you in this direction, you'll feel a little more confident. But now based on this direction, this guy's going down here, up here, and he not only approaches the horizontal asymptote on the right side of the graph, but also the left side of the graph. And so that is where my graph compared to the calculator's graph, very similar. Not 100% the same thing, because they're plotting a ton of points and we're just plotting a couple points. But that's why the graph comes together the way it did. Okay, if you see something you'd like to ask there, then please go ahead and speak up. Otherwise, move on to try question 10. Now, starting with question 10, what I'm going to do is just share the graph, and then if your graph's not looking the same, I can work any and all of the parts, but at this point you should kind of have an idea of your strengths and weaknesses. So in the end, your graph on 10 should look something like this. So in about 7 minutes, I will need you to tell me which parts of this you'd like me to go over with you. so that's actually 8 minutes. So question 10, your graph should look like this. So this should give you some hints about what you might want to ask about. So which parts of 10 would you like me to go over? Sure. So this one does have a slant because the degree of the numerator is 1 bigger than the degree of the denominator. To find it, you have to do long division. Now, I think I said this last class, but usually you don't have fractions and stuff like this, so still good practice though. Alright, the first part of your answer should be x, because x times x squared gives you x cubed. And then you need a 1/4, because 1/4 times 4 gives you 1. And you need it to be negative, because a negative times a negative becomes a positive. So break it up into 3 parts if you need to. Then multiply it to positive 4x. So a positive times a negative would be negative. 1/4 times 4 would be 1, and x times x is x squared. I'm writing it over here because x squared and x's aren't the same thing, so I try not to line those up the same. Okay, and then also times 24. So positive times negative would be, let's put it here, negative. 1/4 times 24 would be 6, and x times no more x's would be x. Change all of the signs and add. Should have an x squared here and a minus 10x here. Again, if you start to have some, you need to be able to do long division for a multitude of reasons, but as long as you've got this part right so that this next part comes right, then it'll be good enough for this. So next up, I would say negative, because negative times a negative gives me a positive. I would do 1/4, because 1/4 times 4 gives me 1, and I don't need any more x's, because times x squared gives me x squared. Okay, you can go ahead and keep on multiplying it, but this is the stuff that's not going to matter here anyway. So this times this would be negative x, and this times this would be minus 6. Change the signs and add. All of that becomes the remainder though. So the slant should be y equals negative 1/4 x minus 1/4. Now, since I have this graphed in my calculator, we can go ahead and visually confirm that this makes sense as well. So again, I have this graphed, and then also, let's just have it graph the slant asymptote as a second line, and it should fit in perfectly with the ends of the graph. In the middle of the graph, it might cross it, but at the ends of the graph, it should be approaching it on the right side and approaching it on the left side. And of course, if you made x bigger than 5 or less than negative 5, you would see it gets even closer. If I change even to negative 10, negative 10 to 10, and negative 10 to 10, you're going to see that this slant asymptote just kind of fits in perfectly there. So when you have a calculator, that's a good check. Okay, others or something specific about that one? Okay, then if you've not done 11 yet, now's the time. So go ahead and move on, and same thing, I'm going to change the graph on the screen to match up the graph for number 11 so that you can scan it for quick mistakes. That's what your graph answer should look like in number 11. So when you finish, if it doesn't look like that, try to find your mistake before you move on. This one went with question 11. So, any parts of question 11 you'd like me to go over to help you get closer to that graph? Okay, then go ahead and move on to question 12. So this will be the last one I put up on the board today, but I do need you guys to try the rest of these before next class. I think there's, what, like 14 of them or something? 14 or 15 total. So here's number 12, what you should end up with on 12. And we'll have time for me to take a few questions from that. But then on the last few, again, if you don't get time to practice those in class, then please do that for homework. This is a B week, so I will not see you guys on Friday. I will only see you on Wednesday this week. But on Wednesday, I will share what the graphs should look like for the last few questions, give you a chance to ask questions on those. You'll get even a little bit more practice on this on the test review. The test review you already have, so you're welcome to start on it early if you'd like to. You did the back page for section 2.5, but Wednesday we will work on that test review, and then that puts this unit test this time next week. So try to get this one under your belt, please, in about the next 6 or 7 minutes, if possible. any help I can give on question 12 to help you get that graph? Okay, so make sure that you finish practicing the other questions so you'll be ready to quickly check those at the start of next class and know which questions you're going to need to ask for help on. And we are down to about 6 minutes, so probably should finish up the question you're on and find a stopping place.